Hello again, grade 12s. We've drawn a graph for a projectile moving downwards. What about when a projectile moves both up and down? Let's join Siwe.
Let's start by watching children jumping on a trampoline. Let's track one child's motion, then analyze the information it gives us. You will see the child moves up first, then stops very briefly at her maximum height before landing back on the trampoline surface. We did a quick time trial with a stopwatch and found that the child jumped 1 meter into the air and stayed in the air for 0.9 seconds before coming down to the surface of the trampoline.
We must be careful when thinking about this situation. Remember that the child is only in free fall while her weight is the only significant vertical force acting on her. This is not true for the time she touches the trampoline. So, our data only refers to the time while the child is in the air. Now let's draw the displacement time graph. Please continue, Siwe.
The graph looks like this. It's important to fill in all the information we know at present. We learned in the last lesson that the time taken for an object to reach its highest point is equal to the time taken to return to its original position. So we know that if the total time for the child's jump is 0.9 seconds, then she will reach her highest point after 0.45 seconds. This is drawn onto the graph. It's possible to calculate the velocity of an object. Any ideas on how to do this?
Yes, by the gradient.
Of course. The gradient of the graph gives us the velocity of the object. To get the gradient of a line, we divide this distance by this one. It's that simple. This is a bit tricky in our position versus time graph because the graph is curved, not straight. We need to draw in a tangent to calculate the gradient. Then we can use this gradient to work out the velocity of this part here. It's not easy to calculate the gradient of a curve unless you understand what the tangent represents. Let's examine one special tangent. Look at this tangent at the very top of the graph. Notice that the line is parallel to the time axis. This means that the gradient of the tangent is 0. Interesting. This proves to us that the velocity at the highest point is 0.
Thanks, Siwe. Let's go to the velocity time graph for this motion, please.
Using equipment similar to photo gates, we measured the child's initial velocity as 4.41 meters per second. Final velocity was 4.41 meters per second. With this information, we can draw a velocity versus time graph for the child's motion. First, we draw the axes, which are velocity and time. Make sure that you label each axis fully, including the units. Then we insert values we know for the child's velocity, which are 4.41 and negative 4.41. Why is the second value negative?
I think it's because the child moved in the opposite direction. What I mean is that when the child returns to the trampoline surface, she is moving in the opposite direction to her starting direction.
Absolutely correct. Now we can finish the graph. We also know that the child took 0.9 seconds for the entire trip and 0.45 seconds to reach the highest point. So we draw a line to connect the points we know. These are from 4.41 meters per second at 0 seconds to negative 4.41 meters per second at 0.9 seconds. Do you see that we have a straight line? This was expected because the child is experiencing a constant acceleration of 9.8 meters per second squared downwards due to the gravitational pull of the Earth. Velocity versus time graphs are actually quite useful because we can calculate both the acceleration that an object experienced and the displacement or distance that an object traveled. This is how we do it. To find the child's displacement, we must find the area under the graph. On the graph, there are two colored triangles. For easy identification, we'll call them Area 1 and Area 2. Do you see that the colored areas are both triangle shapes? Now to find the area of each triangle. The area equals half times the base of the triangle times the vertical height of the triangle. On the velocity versus time graph, the base of the triangle represents the change in the time value, and the height is the change in the velocity of the object. So in area 1, the base is the change in time, so it is equal to 0,45 minus 0, and the height is the change in velocity. That's 4,41 minus 0. Working this out, we get half times 0,45 times 4,41. This gives us an answer of 0,99. Therefore, the upward displacement of the child is 0,99 meters. Interesting, we measured it to be 1 meter. The difference is probably due to the experimental error and also because we are using decimals in our calculations. But for all intents and purposes, 0,99 meters can be rounded off to 1 meter. And this is the displacement or distance we expected. To calculate the area of the second triangle, we use exactly the same method. Throughout this lesson, we have assumed that up is the positive direction. If we get a negative answer, what does this mean? I hope you all got the correct answer. Let's see what Nombulelo thinks.
If up is positive, then down must be negative.
Good answer, Nombulelo. Not so difficult after all. When we get a negative answer, it simply means that the child was moving down. The displacement of the child from the top of her motion is 0,99 meters down. We can now work out the total displacement of the child as she bounces on the trampoline. The total displacement is equal to area 1 plus area 2. So we have 0,99 plus negative 0,99. Therefore, the total displacement of the child is 0 meters. This makes sense because the child returned to her starting position. The gradient of the velocity versus time graph is also useful as it is equal to the acceleration experienced by the child. Let's see. The gradient is calculated by dividing the change in the vertical height, labeled delta V, by the change in the horizontal distance, labeled delta T. Acceleration is equal to change in velocity divided by change in time. Can you see that this looks exactly like the equation for the gradient of our graph? Let's calculate the acceleration of the child according to our velocity versus time graph. Acceleration is equal to the gradient, which is equal to the change in velocity divided by the change in time as read off the graph. This means that we have V2 minus V1 divided by T2 minus T1, which is equal to 0 minus 4,41 divided by 0,45 minus 0. This gives us negative 4,41 divided by 0,45, and the acceleration is equal to negative 9,8. The negative indicates to us that the acceleration is acting downwards, as we expected. Therefore, the acceleration is equal to 9,8 meters per second squared down. The final answer should always be a positive value with the direction in words. But in calculations, we use the acceleration value as a negative value.
And we can use the same value to draw the acceleration time graph for this motion. Show us, please, Siwe.
Here it is. This graph is simply a straight line drawn horizontal to the time axis at negative 9,8. The only acceleration is due to the gravitational attraction of the Earth, so it will not change during the motion of the child.
Well, thank you very much, Siwe. Remember to do the task for this series. Also visit the Mindset website at www.mindset.co.za/learn. Goodbye.